Hey guys, let's take a look at the project against which I'm going to be programming throughout this section. It's a familiar example, and I know you're thinking, man, Paul, why are you always using tank fills? Well, it's something that with all these different students coming from all kinds of different industries, I don't want to use something that alienates a lot of people because they don't understand it, they don't ever work with it, they don't know what an encoder is or something like that. So using this, everybody can understand the concept of filling up a tank and then draining it down. So it's just a very easy, simple example, and it allows us to do a lot. We can work with analogs, we can work with digital, we can control devices, we have a process, we can even write logic to simulate the action of it happening if we want to. So that's why I'm maybe a slave to this model. But anyway, for those of you who don't remember it or haven't seen it before because you skipped it or whatever, let me just go through a quick rundown of what this thing looks like. We've got our tank. This tank's going to hold, I don't know, water or marbles or dead flies. It's going to hold something. Inside of the tank, we have 4 digital level switches. We have one for low, one for low, one for high, and one for high. In case you don't remember the process control section of PLC 1, high and low are your normal process control set points. At any time, your level inside the tank should be as low or as high or somewhere in between, but it should never be below low and it should never really be above high either. In case something goes wrong and we get below the low level, we have a low switch to tell us that we're having an emergency, and that's going to activate an alarm and cause the system to take steps to protect itself from breaking, damaging something, or etc. Same thing, if we get above the high, eventually we're going to hit that high switch, and that's going to do the same as low. It's going to trigger an alarm. It's going to warn the operator, hey, we've got a problem. And the system is going to take steps to protect itself so that nothing goes wrong, if at all possible, to prevent any type of catastrophe. So in process control, low and high are your control set points. Low and high are your alarm or emergency set points. We're also going to have redundant level control on this system. So if you look down on the bottom left of the tank, you see that we have an analog input which is also labeled level. That is going to be a hydrostatic pressure sensor. So what that's going to do is it's going to detect the water pressure at the bottom of the tank. Now the more water or dead flies or marbles or whatever we put in our tank, maybe cheesecake, I don't know, but whatever's inside of the tank, the more of it there is, the more pressure there's going to be down at the bottom. So based on that pressure, whatever that is down at the bottom, maybe it's 0 to 2 kilograms or 0 to 5 pounds, whatever that pressure is detected down there, we're going to be able to scale that into a level in our tank. So we've got an analog level, we've got digital level control, at least at 4 points. Then we have a pump, which is going to pump into this tank to fill it up. And we have a valve, which we're going to open and close. We're going to open this valve to drain the tank down. And what we want to do in the most practical of scenarios, we want to open the valve and disable the pump to drain it down to low. Then, once we get below the low level, we want to close our valve and energize our pump to fill the tank back up to the high level. And we want to alternate between those back and forth, constantly filling and depleting our tank. I can't imagine why we would want to run a system that way in real life, but it's pretty good for learning how to program PLCs. So that's what we're going to do. That's our system. And we can toggle between our controls. We can use digital level for some examples. We could use analog for others. or we could actually use them redundantly such that we rely primarily on the digitals, but we fall back on the analog for redundancy just in case it detects a high high or a low low. So we've got some options in the system we can play around, but the goal in this section is not going to be to program this scenario perfectly. Rather, it's going to be using this scenario to give examples and teach how to program in 5000. So yes, we are going to program this and automate it and see it working on emulate, but by the end, we're also going to do some things that don't work very well intentionally to kind of give an example of some of the limitations of the programming paradigms and just give you an overall idea of how to approach a system when you're laying out your program beforehand.